to the very last bit of this unit, if you will. From what I want to try to get at today, between today and tomorrow, I think it's better that we are able to start this a little bit earlier than later. Because on Thursday we have the half day, and that way I can go back and go through special right triangles with you and Pythagorean theorem, stuff like that. The things that you probably mainly forgot. So between today and tomorrow, the bulk of the things we're going to discuss are going to roll around solving right triangles and reverting back to some of the parts in the angles of elevation, depression style questions as well. What I want to get at here now is that up to this point, you guys have only had to do really one thing in a triangle. You've only had to find one value. Now, what I'm going to ask that you guys start to do is you're forgetting two other things. You're forgetting there's another possible angle. You're forgetting that there's another side. So quite literally, all we're going to be doing now is taking what we've done and doing two more parts to it. And that's really it. You're still solving trig stuff. You're still working through these scenarios. What happens, though, is that there's going to be two different scenarios. When you have right triangles, there are three angles and three sides. You okay with that?
Yeah.
You're always going to have a right angle. I thought you said no.
I said yeah.
Oh, I'm sorry. I can't hear out of this here, so I don't know what's going on. So what happens here is that you're always going to know one right angle, which means there's only going to be how many parts to work with? 5, because there's 2 angles and 3 sides. So what that means is that you can have one of two scenarios. You could be given 2 sides. You could be given 1 side and 1 angle. Now I want you to think here. If you have 2 sides of a right triangle, how many more sides would you have to find? 1. You would have to then find 1 side. Oh, and if you have 2 sides of a right triangle, you have to find the third. What's the easiest way to find that side? Pythagorean theorem. And you would always use. Now, it doesn't mean that you're going to be given the 2 legs, find the hypotenuse. You could be given a hypotenuse and a leg, find a third side, and so on. It could be any of the combination of those 2. But that also means that you'd have to find how many angles. Well, you know one of them, so that means you have to find 2. And then you would find 2 angles.
Did that say find 1 side?
Yeah. Okay. Now, in order for us to find those 2 angles, we're just going to use whatever given information was to us and use trig. Sine, cosine, tangent, and if you're finding angles, you're using the inverse. Using trig inverse. Okay. Whereas if I'm given 1 side and 1 angle, that means I have to find then 2 sides using trig. And then I have to find 1 angle via subtraction.
That's all it is.
Yes, sir.
Alright, so if you're already going to have 1 angle with technically 2 because now you
Right.
get another angle. And then you get the other angle by subtracting by 180. And then, so if you do that, how would you know which angle would be like the opposite?
It depends on where you start. And I have plenty of examples to show us. Because remember, like I've been saying, trigonometry is all about perspective. If I'm at this, if I start at 34, this is my opposite. If the 34 was here, this would be its adjacent. So it really depends on where you are in the triangle of what parts you're trying to find. And what I want to do is show you guys how that you're how you set this up in such a way that you don't, all right, so let me rephrase that. I want you to set it up in such a way so that you're always reusing the information that they give you within the problem. Because here's the deal. If you're going through the problem and let's say you make a mistake. If you use a number in a triangle that's already wrong to find another part of the triangle, will that ever be right? No. But if you start over with the given information, you have a chance of getting something correct. And it all stems from excuse me, understanding how that by reusing givens and rewriting steps out, it forces you to slow down. And that's what I'm trying to get you guys to do. So if I look at this, and I want to work through the idea of solving this right triangle, I'm first of all going to show you guys what it's going to look like when we label it. Capital letters are always for angles, and then we use lowercase letters for their sides opposite. So in this case, opposite the A was little a, opposite the B was little b, opposite the C is little c. Now, doesn't that look like using Pythagorean theorem? And that's why we use that. Lowercase letters are always for side lengths. They're always opposite their capital letter counterpart. So in this problem here, I have 34 degrees at angle A. I have 17 for side C. But that means I have to find how many angles and how many sides? One angle. I have to find one angle.
Two sides.
And I have to find side little a and side little b. So this is telling me what I need to solve for. The easiest one is the angle. Because, Dr. Brown, you were saying here I can subtract everything from 180, but if I take 90 out of the problem, how many degrees are left? 90. Remember, the two angles are always complementary to one another in a right angle, or right triangle, excuse me. So what's the complement of 34? 56. So that's the easy one, okay? That's easy. But what I'm going to do then is look at this 34. A is its opposite. B is its adjacent. And 17 is the... So in order to solve for the little a, what trig function am I going to need to use? What works with opposites and hypotenuse?
Sine.
Sine. So that means the sine of 34 is little a over 17. And now you're at a problem you did last week, which I know that all of you guys can do. To get the a by itself, how do you undo the division? Okay. And you always write down what you're going to put in the calculator before you put it in. And then you type it in and figure it out. To find b, what trig function am I going to use knowing that I have a 34 and a 17? 34, I'm going to use cosine because now that's the adjacent. And this is the stuff that we're doing. You're picking one spot of something that you're given. I'm given the 34 degrees and I'm given the 17 on the hypotenuse. I'm going to use those two parts to be able to solve everything else out. Because I can. Because when you think about the parts within SOHCAHTOA, sine is the opposite hypotenuse. Cosine is the adjacent hypotenuse. Tangent is the opposite over adjacent. So if I have an angle and a hypotenuse, I'll be able to figure out an opposite and adjacent. That's the idea here. That's the idea. Sure.
How does the lettering work?
Lettering always works the same way. Lettering always works the same way. Capital letters are the vertices, just like they have been. Capital letter looks at its lowercase counterpart.
Oh, okay.
Okay? They always look at their lowercase counterparts. It's a very common way that you will start to see from like today outward. We do this a lot with sides. Instead of saying segment AB and segment AC and things like that, it's easier sometimes to write it as lowercase because then you can see that, oh, this is a squared plus b squared is c squared. That's why I'm going to do it this way. Okay. And then I just press buttons on my calculator and I get answers. What did you guys get for side A?
9.5.
951?
9.
What'd you guys get for little b? Now ask yourself, does that make sense? Does the smallest angle have the shortest side plane?
Yeah.
Yeah. Does the larger angle have the largest? It's the hypotenuse and stuff. Okay. Yes, sir.
He's
09? Oh, thank you. That's the idea. Yes, ma'am.
How did you know that angle B was 56? Because this thing says 90 plus 34, and then you have to add 56.
Yes. Or remember, these two angles here, since this is 90 degrees, there's 180 so far. Take out the 90, what's left? 90.
Yeah.
So these two angles in a right triangle will always be complementary. So the complement of 34 is 56. That's just a shortcut way of doing it. Or you can go the long way, just subtract 180, subtract 90, subtract 34, and you'll get the same answer. Right? The lights did flicker, right?
Yeah.
I mean, the projector doesn't.
The Wi-Fi just went down.
I got power though.
Well, you're on a laptop.
Let me guess. You writing this down?
Wait, did that happen to everyone?
Did it happen throughout the whole school?
How would you know?
Hold up, guys. Hold up.
Alright, let's leave.
This is the best last period ever. It's white? What do you mean it's light outside? White? When would it be light outside?
Imagine what's going on in the food.
I don't know if it was the rest of the building. I don't know if there's not a lot going on around here, but this light bulb is burnt out again. It's a good thing I just got a new light bulb.
It's like the smart board program.
It's not gonna work.
That's weird.
Sweet.
We do everything by whiteboard now.
No.
Right triangle. I have a side and an angle given to me, which means I have to find another angle and two sides. Always, always, always reuse given information. So when I'm looking at this, yes. When I'm looking at this, that means I have to find angle A. I have to find little b and little a, because I have little c. Well, angle A is the easy one. What do you get? Now, what angle are you given? 70. I'm given the 70.
Oh, I thought that was 7.
Oh. I'm given the angle 70, which makes B the opposite. What trig function am I going to use to find B, knowing that 15 is a hypotenuse? Sine. So the sine of 70 is my opposite over hypotenuse. Just multiply over. Reusing my given at that 70-degree angle. I go back to the idea of finding A. Side A is what in relationship to the 70? It's the adjacent. How do you find the adjacent knowing the hypotenuse? Cosine.
This is all it's in? Oh.
And that's what we're setting up. We're going through and reusing given information over and over again to solve the full triangle. Okay? So, yeah. How many degrees are in a triangle? Take out 90, how many are left? What's 100?
Just let me think, don't laugh at me.
So what plus 70 is 90? Like I've said, in a right triangle,
20.
the two ang-
Yeah.
the two angles that aren't right are always complementary.
Okay.
That's why I just say what's the complement. And that's what we're doing.
Weights of the little letters or the sides, right?
Yep.
Sorry.
Yep.
She left at the beginning of the class period.
Take a minute to solve it. Show all the work, write it out. So guys, this is your two sides, find a third side, find two angles. You have to find angle A, angle B, and little b. Pick an angle to start with. If you start with angle B, 15 is its adjacent. 18 is the hypotenuse. What trig function is that? Cosine. So that means that the cosine of B is 15 over 18. To find an angle, what button do you have to press? Inverse.
But how do you know
What do you mean?
what to use to, what trig function? No, not that. I'm
So-
saying like,
Oh, you mean like which number's the thing?
yeah.
Oh,
It's all about what angle you're starting with.
if there's
That's why if I said if you start with B, if I start at B, 15 is its adjacent.
Okay.
18 is always a hypotenuse.
Okay.
Now, if I switch it around and I go up to A, 15 is now it's now the
I
opposite.
think she means like,
So it doesn't matter. So it does not matter.
What do you mean?
It doesn't matter which angle you pick.
No. You pick either one to start with, because you're just going to use two trig functions. That's all.
I think she's confused with the numbers.
Like-
You always choose the,
Like how did you just know to pick
because the
the adjacent and then the hypotenuse? Why couldn't it be the opposite?
But because I said, hey, let's start and find angle B first.
Okay.
If I wanted to find angle A first, 15 is its opposite. 18 is always a hypotenuse because it's across from the 90. If I started at angle B, 15 is its adjacent. Because the opposite and adjacents flip-flop depending upon which angle you're at.
and there's no value over there.
Right, and since there's no value given here, I need to use my given here.
Oh, but what if you find the side?
Don't, well, you can still find the side first, but don't use that side to find the
Okay.
other.
That's what I was doing.
Because if you do, let's say you got that side wrong, will either of your angles be right?
No. Okay.
So by doing it this way, let's say you accidentally typed in 15 over 28, and you put that angle in here, and then you did sine of 15 over 18. You could get this angle wrong, but get this angle right. That's the whole idea. By reusing the information that you start with, you run less of a risk of screwing something up for long.
Makes sense.
Okay, cool. So then this one was sine. And then this was a b squared plus 15 squared is 18 squared,
Yes.
and whatever that equals. I'm not worried so much on that one. I have 6 of these for you to do.
Yay!
I was just chilling in the shower.
Superman on Netflix.
What?
They put Superman on Netflix.
Hey, I got the same one. Yeah. I've seen it. I have that movie. But I got it on calculator. If I you don't want to watch it.
Do those 6, please. Write them out, show the work, guys. Write them out, show the steps, okay? Yeah. I know.
I'm kidding.
Well, here, just take pictures in there.
Hey, hey.
Just take a picture real quick.
Last night.